Okay, last question for this quiz 1. Okay, the last question is talking about the speed time graph. Okay, so we want to find this one slightly easier because quite straightforward. We want to find the speed at 25 seconds. Okay, so how do you do that? Let me just redraw the graph. Okay, have a rough sketch over here. Okay, so this is the speed and the time graph. So remember, the method that we always use to solve this is only two methods. One is using the gradient. Okay, and second one will give you use the method of area under the graph. Okay, usually it's just these two. Okay, I would say 90%, 80 to 90% of the time. Okay, so very first question. Okay, maybe let me, before I even talk about the question, let's highlight what are all the possible coordinates that's given available for us. So this first coordinate is 30 and 24. Over here we have also 120 and 24, and last but not least we have also this, which is 140, 0. Okay, one more thing in fact I missed out. This one will be a 0, 0. So 4 coordinates, 1, 2, 3 and 4. Always do this first. Write down all the possible coordinates that you can find. Next part, so part number 1, part A, we are supposed to find the speed at 25 seconds. So where exactly it is. So let's go and take a look. So this is 30 over here, 25 should be somewhere here. So let's draw a line, dot. So we want to find the speed. So let's give this a coordinate again. So this is s, 25. Oh, sorry, the other way around, 25, s. Okay, so this is the coordinate. So let's think about it. So the two methods, which method can we use to solve it? Can we use gradient, or we use the area under graph? Okay, so if you think clearly, the method we should be using will be the gradient. And how are we going to use the gradient? So simply because of the fact that, okay, the coordinate that we are finding is on this line. Okay, the line over here. So as long as we have the information about this line, we can solve the unknown coordinate. So basically, how we are going to just use the gradient. So gradient of the line actually equals to y1 minus y2 over x1 minus x2. Okay, so based on the information that we have, so we have this coordinate and we have this coordinate on this line, first the start and the end of this line. So I'm going to use these two. So 30, 24 and 0, 0. So I'll try to find the gradient of this line first. So I sub in, this is x1, y1, x2, y2. So it's 24 minus 0 over 30 minus 0. Okay, so 24 over 30 will be reduced, will be 4 over 5. That will be the gradient. So how is this gradient going to be helpful? This gradient, once you got this, I'm going to use another two coordinates, okay, to form out the equation. So now I have the coordinate, unknown coordinate, which is 25s, right? I'm going to use this and 0, 0 to try to find the gradient as well. Because by using these two coordinates, we're going to get back the same value. So all we need to do is gradient also equals to 25, sorry, it should be s minus 0, this is y2 minus y1 over 25 minus 0, and this should give us 4 over 5 as well. So it's s over 25 equals to 4 over 5, and to solve this we simply just cross multiply or bring the 25 across. So s will be equals to 20, and the unit will be speed will be meter per second. Okay, so in short, for the first question we are using the gradient method. So the whole idea, if you don't quite understand, so basically the whole of this line, the gradient is the same. Gradient is the same throughout the whole line. So this method that we are using is the concept. Use any 2 points. The gradient of these 2 points and the gradient of these 2 points, they will be the same. So we are just trying to equate the two gradient together and solve the unknown. Okay, so this is for part A. Okay, they are a bit stingy to just give 1 mark for this. Okay, so next part B, we want to find a deceleration. Okay, deceleration. So how do we find it? Equals to negative acceleration. So must take note, deceleration is actually negative of acceleration, which is equals to, and how do we find the acceleration? Acceleration is actually equals to the gradient, negative of the gradient. Okay, so how do we find the gradient? Basically is y1 minus y2, or y2 minus y1 over x1 minus x2. So the gradient that we are looking for is the last 20 seconds. So if you look back to the graph, the two coordinates that we're going to use, of course, will be this. Let me just change the color, maybe like blue. So this 120, 24, and this 140, 0. So I'm going to just bring it down. Okay, 120, 24, and the other is 140, 0. So these are the two coordinates I'm going to use. Okay, so to be safe, I label them x1, y1, x2, y2. So I sub them inside with a negative in front. So y1 will be 24 minus 0 over x1 will be 120 minus 140. And if you press your calculator, it's basically 24 divided by 20, negative 20, and that gives us negative 1.2. Therefore it's just 1.2 meter per second square. Deceleration will be this unit. Okay, so that will be for part C. Okay, so part D. Part C will be the total distance. Okay, so total distance, of course, the thing that comes to your mind should be your area under the graph. Okay, area under the graph. So we want to find for the whole journey. So whole journey, the graph is basically a trapezium. So if I were to sketch it out here, it looks like this basically. Okay, it's a trapezium. So area of a trapezium, straightforward. This is A, the two parallel side, B, and the height will be here. So it's half times A plus B times height, area of a trapezium. So what is the value of A? B is quite straightforward. B, we have, based on the graph, we have 140. And over here on top, the distance is 120 minus 30. If you look at the graph, because it's 30 and this 120, so we need to just find this, minus off. And the height, also quite straightforward because it's given, is 24. So we have everything we need. So all we need to do is sub in area equals to half times A plus B, which is 90 plus 140 times the height, which is 24. And based on this information, so 90 plus 140 times 0.5 and times height 24 equals to 2760 meters. Okay, so this is one way. Of course, if you are not very familiar with the trapezium formula, you can also break it down. Find a triangle, find a rectangle, and find another triangle. You can break it down to 1, 2, and 3. No problem. Okay? Alright, last part. Part D. Find the average speed. So average speed equals to total distance over total time. And total distance we've given is 2760. The total time is in meters, and the time is actually 140 seconds. So very straightforward. Okay, so in this case, if you get the answer, it will gonna be a weird number. So it's 19.5/7, or if you can round off to 3 sig fig, it will be 19.7 sig fig. Okay, so you ask me, okay, should we give an exact value or can we round off? Okay, for split wise, I think it's fine. I think they will be accepting both. Okay, but if this is money, do not give in fraction. Okay, so just take note of that. Right, that's for this question.